So we talked about that project that they're trying to do in New York City with the abandoned trolley station underground, being able to get that light there. And, we can see here in this picture the, plane mirror. But then, here we've got a different kind of mirror, and that's what we're going to look at today and what's going on with what's called concave mirrors. So concave mirrors have the shiny side on the left side. This is where the reflected rays go. The focal length is positive, and the dark side is behind the mirror. So you could draw this out on your sheet of paper to see that. And on your notes cover page, I encourage you to find M5, which you can draw out on there as the center and the focus. It turns out the focal point, if we double the focal point, we'll get the center. And we'll have our radius there is the full, from the center to the mirror. And so the only thing that really is probably critical here is the radius is equal to 2 times the focal length. And yeah, that works for any concave mirror. And that's what we look at here. All right, so on M6, what I want you to do is get a straight edge, and you already have a pre-made kind of picture here with this. You can draw, your ray coming in. It hits and then goes through the focus, so you can draw that. We can draw one down here, ray hitting, going through the focus, and we can draw one close, a ray hitting here, and then going through the focus. And so, yeah, and so we can see that here. And that's what we saw in our lab. The parallel rays hit and then go through the focus. So when we draw ray diagrams with this, to see what our images look like, we draw these 3 rays. We have the parallel ray, we have the focal ray, and we have the center ray. And you guys can write these out. And these are the 3 rays that we can draw. Now we only need 2 out of the 3 to be able to construct an image. And yeah, and we can do that. So yeah, go ahead and pause the clip and write these out. And when you're ready to continue, you can hit play. All right, so let's draw this out on M7. Let's say that this is an object out here that's further from the, the focus in the center, kind of far out there. What would our image look like if we're, way out and we're looking at ourselves in the mirror? Maybe this is our face and we're looking at ourselves. What would it look like? So let's draw the principal ray first, or the parallel ray rather. The light comes and hits, goes through the focus just like we saw in our lab. We can draw our focal ray straight through the focus, then it comes out parallel. Then we can draw the center ray straight through the center and back. And now these rays reflect, and they end up being right here. And this is where all the reflected rays come back together. So if I'm here and I'm looking at myself in the mirror, I see myself upside down, and I see myself smaller. And so if we look at the 3 names, if you guys remember back from the 3 criteria that we wrote down, nature, orientation, size, it is a real image because it's on the shiny side. The image shows up on the shiny side. The image doesn't show up on the negative side. It is inverted, and it is reduced in size. It's smaller. And so you need to remember these specific names. And that'll be critical there moving forward, and that's good there. All right, so let's go ahead and try this one here. If you want to draw this out in M8, and on this one, you're only going to be able to draw 2 out of the 3 rays and construct the image. And so, yeah, go ahead and pause the clip, use your straight edge, and give this a try. And when you're ready to check, you can hit play to continue. Okay, so we've got our principal ray, or parallel ray, focal ray, and we're not able to draw the center ray, which is from the tip through the center to the mirror and back. And so the image will show up here. And so we can name our image. So go ahead and pause the clip and name the image based on the 3 criteria. And when you're ready to check, you can hit play to continue. All right, so we should get real. It's on the shiny side. It's inverted, and it is true. It's the same size, and so it ends up being right below it, same size. And a couple people were asking about this today with this. You know, if it's a little bit off, that's okay. We're going to be able to calculate these as well, and so we'll be able to confirm those, and that's good there.